Today we're doing section 13.3, solving quadratic equations by completing the square. Okay, you're doing homework section 13.3, page 588, 1 through 29 odd. All right, so when it says to solve it by completing the square, we don't have the option to use another method. Our methods for solving quadratic equations, we've got our square root method, which we did yesterday, where we root both sides. Okay, but it doesn't work if we have a linear term. So x squared plus x. Remember, this is our linear term. When you have x to the first power, it's not going to work. We can't take the square root of x. So it's limiting. Our graphing method we did last week, which is a lot of work. We had to find the axis of symmetry, then the vertex, and then we factored, we found our y-intercept. There were about 10 steps, and so it's very timely. And if you're not factoring, if it's not factorable, then you don't have your roots, and so you've got to go to a table. It's just lengthy, okay? We have the quadratic formula. That's number 3. We haven't learned that yet. That's where you basically figure out what is A, what is B, what is C, and then you substitute it into a formula. This works all the time. All the time. With the graphing method, when you're factoring, if they're not whole number roots, that makes it hard. It's just lengthy, but quadratic formula works all the time. The only limit there is to this is if you're not doing the proper order of operations, then it tends to be, you'll get it wrong. The other thing is if you have big numbers, the quadratic formula can be hard, difficult, taking the square root of 5,536. All right, and then we have the factoring method, which is what we started with. We factor the trinomial. We use our zero product property, but not everything is factorable, so that's limiting. And then there's completing the square. Completing the square always works. It's probably the single most important method in algebra. It will be most used later on. You'll be tested on it you'll basically be tested on completing the square on your SAT. It will come back in higher level math. Teachers like it a lot more. Anyways, you'll use it the most. So this is the method. Put some time in here. All right, so let's start by completing the square. Okay, so before we get going, I want to review some homework problems that we did last night. So you'll notice that like on number 16, oops, I didn't mean to do that. Let's go with this. On number 16, we had, or number 28 through 37, you had things like, let's see, number 29 was x squared minus 2x plus 1 equals 16. Well, what they're giving you here is a perfect square trinomial, and we have to factor that. I've recognized that. Now, I'm going to remind you about the perfect square trinomial rule. This would be like a plus b times a plus b. Oops. Let's just start with a plus b squared. What that really means is a plus b times a plus b. And if I FOIL that, right, I'm going to get a squared plus ab plus another ab. I can put that right here, right underneath. And then plus b squared. So that makes a squared plus 2ab plus b squared. Now, I'm going to remind you, the shortcut for this is to check to see if I factored it right. Multiply these two together. Well, we know that if I square the a, it's going to look like this. I know if I square the b, it's going to look like this. So to check the middle term to see if I factored correctly, what I do is I multiply these two together. I get ab, and then I double it times 2 because we have 2 of them, right? 1 and 2. We got one AB here and we got one AB here. So a plus b squared is equal to a squared plus 2ab, plus b squared. So I'm noticing this is a perfect square and this is a perfect square. Okay, to get that minus sign, I have to have it here. Now, I can check myself by multiplying these two together. I get negative 1x, right? And if I double it, is that what I have up here? It works. So that is the correct factoring. Okay? So I'm factoring it. It goes to equal. Now I'm ready to root both sides, and what I get is the absolute value of x minus 1 equals 4. Now, I keep it, I have to lose the absolute value before I can get rid of the 1 and isolate the x. So, to lose the absolute value, I have to set this equal to plus or minus 4. So notice to lose the absolute value, I have to set it equal to plus or minus 4. Got it? Okay. And now I've got plus 1, notice, and then I have x equals. Notice I put the 1 first, plus or minus. Please write it like that. And that basically gives me two equations, 1 plus 4 and 1 minus 4. This simplifies to 5, and this simplifies to 3, negative 3. So my solutions are negative 3 and 5. Pause the recording if you need to write this. Okay, while this is up, I'm going to give you another one. Answer over here, and you are going to do the next one, which is let's make it not so perfect of a square. Let's do c squared plus 16c plus 64 equals 15. Okay, pause the recording and try that one on your own. All right, let's check our work. So this should have factored to c plus 8 squared, right? Equals 15. I'm going to root both sides. And I get the absolute value of c plus 8 equals rad 15. To lose the absolute value, I'm going to have to add plus or minus rad 15, right? Plus or minus to the rad 15. And all right, we're checking our work, and now I'm ready to subtract 8. I get c equals negative 8 plus or minus rad 15. And that's it. We stop there. That is our solution. Negative 8 plus rad 15. Negative 8 minus rad 15. If I wanted to, and this were a word problem, I could find the square root of 15 and then combine it with negative 8 and negative 8 minus the square root of 15. All right? So that was work from yesterday. Now we're ready to complete the square. Okay? So in order to complete the square, we've got to make, this is not a perfect square. Now, I know a number of people that are like, oh, well, I can factor that. Well, that's not how they're asking us to do it. They're asking us to solve by completing the square. So in order to do that, I have to turn this polynomial into a, x squared plus 6x minus 7 into a perfect squared trinomial. In order to do that, okay, let's call this ax squared plus bx minus c, right? I'm going to have to get rid of that c, that constant term. So in order to do that, I'm going to add 7 to both sides. Now, what I've done is I've freed up that spot, that constant term spot, and so I take the middle term's coefficient, 6. I have to divide it by 2, right? And then I'm going to square it. I always take the middle term's coefficient. So b divided by 2 and then squaring it. If that was ax squared plus bx. Right? I'm always taking whatever the coefficient of x to the first power is. And so then we get 3, we have to square it, and it becomes 9. So I can do anything to an equation as long as I add it to both sides. So I'm going to add 9 here, and I'm adding 9 here. It's keeping my equation in balance. But what I've done is I've created this perfect square trinomial here. I completed the square. By adding the 9, that is the completing the square. So now I'm ready to factor. I know it's going to be, oh, why am I doing that? It's a parenthesis. Okay, so that factors to x. All I really have to look at is this one and this one. Plus 3. It's a plus sign, so it's 3 squared equals 16. Okay. Now, I'm going to root both sides. I get the absolute value of x plus 3 equals 4. The absolute value of x plus 3, to lose it, I have to set the 4 to plus or negative 4. Same thing we were doing yesterday. Subtract the 3. Notice the minus 3 comes in front. Negative 3 plus or minus 4. That means negative 3 plus 4 and negative 3 minus 4. So that makes 1 or negative 7. Okay. We're going to continue. Pause the recording if you'd like to write this down. All right, completing the square trinomial. Remember, every time we're taking that middle term. In fact, I can factor it. So if I factor this, when I divide that, what's the root of that? It's an x. And when I divide that by 2, remember, oops, sorry, I didn't mean that. It's 3. And then basically, if I take that 6, I divide it by 2. It's always divided by 2. I get 3. When I square it, I get 9. So when I square that term, I get this. When I multiply that term by 2, I get that. So we're doing the opposite. We're dividing by 2. All right, pause the recording and try the next few on your own. All right, let's check our work. So when I take the middle term, I divide it by 2, I get a 6. So this should be m plus 6 squared, the quantity of m plus 6 squared, if I'm factoring. And when I square that last term, it becomes a 36. Divide the middle term by 2, I get a 9, negative 9. So y minus 9 squared, the quantity. And then when I square negative 9, I get positive 81. Okay, divide negative 14 by 2, I get negative 7, so that's k minus 7. When I square the negative 7, I get positive 49. Okay, this one is a little bit different. First of all, remember in this, we know that in a perfect square trinomial, it's ax squared plus 2ab plus c. Well, I know to get one of these, whatever this is, or this, I know that I'm going to have to divide it by 2, right? Because I had an AB and an AB. So I know that this is going to have to, that will have to be a 10t. So first, when I'm factoring this, what's the root of 4t squared? It's a 2t. Now, what do I have to multiply that by, that 2t by, in order to get that negative 10t? That would have to be a negative 5. because how I check my middle term, okay, if I'm going to check to see if this is correct, this squared makes 4t squared. This squared, what does it make? 25. That's what goes in there. And when I multiply them together, I get 10t. But if I double it, I get that 20t. So that is correct, the 25. So it's 2t. What's the root of it? It's 2t of 4t squared. And then to get half of negative 20t, I would have to have a negative 5 there. And it has to be squared. Okay? This isn't a game breaker. If you don't get that one, we can still keep going. It's just how to deal with the lead coefficients. All right, so let's try this again. I'm going to complete the square. The first thing I need to do is make an empty space for my constant term to make this a, so I'm going to subtract 5. I'm then going to divide the middle term by 2. Why don't you guys try this one? Okay, now let's check our work. So I'm dividing the middle term by 2. And I get negative 4. I'm going to square that. It becomes positive 16. So I have to do it to both. A big mistake is people forget to add it to this side. And if you don't do it to both sides, it's not a property of equality. Your answer will not be correct. So to factor this, again, it becomes really easy, guys. I'm doing, what's the root of x squared? It's x. What's the root of 16? It's 4. To get that negative sign, it's got to be this. When I multiply those together, I get negative 4x. Double it, I should get the middle term. But you don't really even have to check these once you make the perfect square. Okay, now I'm going to root both sides. I'm going to take the absolute value. Then we set rad 11 to positive or negative. I lose my absolute value, so I get x minus 4 equals plus or minus rad 11. I'm adding 4 to both sides, and then I get 4 plus or minus rad 11. Okay? And that, that is your answer. We don't need to change that. I want you to keep it in radical form. It's far more accurate than estimating it. Okay, the next one, solve by completing the square. So we have an odd number in the middle. It's going to be not as pretty, but it'll still work. Step 1, same step, subtract 6. Step 2, I'm going to take the middle term and divide it by 2. Negative 5, okay? We're not just taking the 5, we're taking the negative 2. Negative 5 divided by 2, and then we have to square it. Square the numerator, square the denominator. Pretty easy. It's 25 over 4. So I'm adding that to both sides. Now, in order to add negative 6 and 25 fourths, I have to convert this to a common denominator, right? So I'm going to be multiplying by 4 over 4, fancy 1. And then we end up with negative 24 plus 25 over 4. Okay? That's because I multiplied by 4 over 4. Okay? All right, we're ready to factor now. On this side, it becomes very easy. The root of that is an x. We know it has to be a minus sign. Now, I've got the numerator, which is a 5. I've got the denominator, the root of that is a 2. So it's basically going back to where we were. Okay? Equals 1/4. Okay, now we're ready to root things because our quadratic is alone. So we get the absolute value of x minus 5 over 2 equals the square root of 1 over the square root of 4. So x minus 5 over 2 equals 1. The square root of 1 is 1, and the square root of 4 is 2. And that's a plus minus, right? Lose the absolute value. I'm going to go over here and go back to the PowerPoint. I can fit it easier. Okay, now I have to add 5/2 to both sides. So I get 5/2 plus 1/2. This is not hard fraction work. There's common denominators, guys. The only thing is the 24/4 that becomes. And then we end up with 6/2, which is 3, and 4/2, which is 2. All right. Next one. Now, given a choice, I would not solve this by completing the square because this is factorable. And it would be easier. But because they said solve by completing the square, I'm using a method. So now I have to take that -7, I'm dividing it by 2, and then I'm going to square it. -7/2 becomes 49/4. Adding it to both sides. Now I'm ready to factor. Why don't you guys pause the recording and try and solve this on your own. Now check your work. This should factor to x minus 7/2. I wouldn't have written that step. Over 49/4. Now I'm going to root both sides. I'm going to lose my absolute value, so I get x minus 7/2 equals 7/2. Plus or minus, don't forget that. To lose the absolute value, we set it equal to plus or minus 2. Now I'm adding 7/2 to both sides. It didn't show it because I'm out of space. Plus 7/2 plus 7/2, and that's what we get. And so we get 7/2 plus 7/2 is 14/2, and 7/2 minus 7/2 is 0. 2 solutions. I think it would have been easier to factor, but just wanted to show you we can do it this way. Solve by completing the square. All right, lead coefficients. So first step, going to be the same thing. Add 4 to both sides. Now, in order to truly make this a perfect square trinomial, they do not have lead coefficients. So we have to get rid of the lead coefficient of 2. So what do I need to do? Divide all terms by 2. So then I get x squared plus 7/2x equals 2. Now, what makes this a little bit cringy is that 7/2, and we're dividing it. Remember, we always take the b term and we divide it by 2. Well, 7/2 divided by 2. But we don't divide fractions. Instead, we multiply by the reciprocal. So then you end up with 7/4. Okay? Remember, we're doing that, and we square it. So that becomes a 7/4, and then we have to square it. So it becomes 49/4. Add 49/4. I'm adding 49/4. Now this, I'm going to have to multiply by 4/4. So that becomes 8/4 plus 49/4. 8/4 plus 49/4. So that makes 57/4. Why am I not remembering that? Oh, that's why, because it's over 16. I forgot to square the denominator. Okay. Wow. Now, what that means is that I've got to do a common denominator. Sorry, guys. I knew something was looking funky. I've got to multiply by 16/16, so that makes 32/16 plus 49/16. And when I add those numerators, it's 81/16, which happens to be a very pretty number. I'm going to factor on the left side to the root of x squared is x. The root of 49/16 is 7/4. Remember, it's squared. And then we add those two numerators on the right. Now I'm ready to root both sides. I'm really liking this because I like the number 81 and 16. They're perfect squares. So I get the absolute value of x plus 7/4 is equal to 9/4. And to lose the absolute value, I have to set it equal to positive or negative 9 over 4. So now I'm subtracting 7/4. And then we get negative 7/4 plus or minus 9/4. And so we get 7/4 minus plus 9/4 is 2/4. And 7/4 minus 9/4 is negative 16/4. So it's 1/2 or negative 16. Negative 4, sorry. All right, that was the lesson. I'm going to give you one more that you can do and check. All right. Here we go. Pause the recording and try the next one on your own. Okay, here we go. Subtract 1. I'm going to divide all terms by 3. Now I'm going to take the middle term, divide it by 2, and then square it. Negative 5/3 times 1/2. We don't divide by fractions, we multiply. Times 1/2, so it's going to become negative 5/6 squared. So that becomes 25 over 36. I'm adding 25 over 36. Okay, I'm going to need a common denominator on the right. I'm going to need a factor on the left. The factor on the left is pretty easy because this is an x. We know it's going to be a minus, and that'll be a 5 over 6. Boom. Now over here, I'm going to have to multiply by 12 over 12. So it becomes negative 12 over 36 plus 25 over 36. So that becomes 13 over 36 when I simplify it. Okay, I'm going to root both sides. And then I get the absolute value of x minus 5 over 6 equals rad 13 over 36. Over 6, sorry. That's a perfect square. So now I'm adding 5/6 to both sides. Okay, let's take a look at this. It's 5/6 plus or minus rad 13 over 6. We can write that, since the denominator is the same, 5 plus or minus rad 13 all over 6. Okay? And that, my friends, is our lesson.